Hello and welcome back. Today we're going to look at Module 6, Learning Objective 2, where we want to explain productivity's role in its determinants. And then two other objectives in Learning Objective 2 are to describe why productivity is so important and demonstrate how productivity is determined. So let's go ahead and get to it. Okay, the first thing we want to do is to look at why productivity is so important. And a country's standard of living does depend on its ability to produce things. And this is very similar to the concept that we looked at in Chapter 1. Okay? So if you think about it, the reciprocal relationship between households and businesses, the more households sell their factors of production of land, labor, and capital to businesses, the more then businesses can churn out in terms of output. So one of the equations I like to use with students is a real simple one when we talk about productivity. It's just outputs divided by inputs. It's very simple, but it kind of makes our point pretty easily. So if we think of our inputs as our factors of production of land, labor, and capital, then everything that we get out of our economy in terms of our goods and services then would be our gross domestic product, or GDP. And we'll just call that real GDP because it would actually be without inflation. So our output becomes our real GDP and our inputs become land, labor, and capital. In a business situation, we're really interested in looking at each of these factors of production, perhaps independently. So we're going to change up some terminology, but remember it's still based on these same ideas that we presented back in our first model in Chapter 2. So instead of calling it land, because that would just be too easy, we're going to say land refers to natural resources. And in thinking about the idea of labor, we can have a lot of people, but that doesn't necessarily mean that they are skilled or that they have a lot of potential to produce things. So what we do is we take labor and we divide it up into people. So the amount of labor, which we'll just simply call labor. Okay, so think about it as the number of people, and that's based upon the population. And then we also can take labor and divide it up in terms of the skills and abilities that the people have. And we like to call this human capital because that's really, where we get things like innovation and innovation and research and development and those kinds of things. Capital remains capital, so that's kind of nice, but when we're taking a look at these things, well, I'll show you in just a few moments. So capital still becomes those things that we use to produce output. So things like machinery, buildings, structures, things like that. Okay? So we can take a look then, and sometimes we want to measure how effectively are we using each of these. So one question we might ask ourselves is how effectively are we using our natural resources? How effectively are we using the amount of labor that we have? How effectively are we leveraging things like educational dollars? How effectively are we investing our capital to get a return on that capital? Remember, capital isn't money. In this case, it's capital in terms of machinery that we use to produce other goods and services. So from that discussion, you can kind of see why productivity is so important, but let's go ahead and take a look at this a little bit. So when we are very productive, then our GDP is higher. And if our gross domestic product is higher, that means that businesses are buying a lot of factors of production, which in turn means that incomes are higher. Okay? So when productivity increases, so do living standards because of that reciprocal nature that we looked at in the circular flow of the economy. So then we want to ask ourselves, what determines productivity and growth rates? Well, one of the things is physical capital per worker. And this, what we're doing here is we're taking the idea of just measuring how much capital, right? So the capital of the machinery, and we're measuring it on a per worker basis. We could measure the capital on a per natural resource base. We can isolate any one of these variables to kind of measure if we make a change here, how does that work in terms of the other variables? Again, going back to that idea of land, natural resources, labor, labor itself, as well as human capital, and then physical capital. Okay? Now, we use the term K over L because K over L says, well, here's our capital, okay? And the reason we use a K is after Karl Marx, but that's actually capital, okay? Over divided by the number of workers that we have. So this would be capital per worker or per labor, okay? So when the average worker has a lot more capital at their disposal, then what would happen is if we increase the capital per worker, we would likewise increase output by worker. So there is what we call constant returns to scale in this particular model. Let's see how that works in other variables. Another variable would be the human capital per worker. And again, this takes a look at what is the knowledge and the skill level that workers have. And if you're an employer, you're thinking about, well, should I provide tuition reimbursement? Should I train? And what kind of people should I actually hire? So another way we can look at productivity is we can say, well, what is our human capital per our labor force, or the number of individuals per worker? Okay, so this isn't rocket science here, but you know, productivity is higher when the average worker has more human capital. So if we increase our human capital, we increase our output per labor hour. Okay, so that's just all this bottom portion is showing. Again, the idea of constant returns to scale. If you make an investment in training, if your training dollars go up, or if your Pell Grants go up for an economy, then what's going to happen is your GDP is going to increase as well. So that's why we see the government doing some of the things that it does in terms of expenditures, because it really wants to increase output or productivity, and then thereby increasing gross. Another one we can look at would be natural resources per worker. So in this case, we're just going to take N, again, very similar to that labor idea that we talked about before, land idea that we talked about before, and then we're going to divide that by our labor force. Okay, and again, what we want to do, the more natural resources a country has, then the more that they can produce. And that kind of makes sense if you think about rich countries such as Saudi Arabia and other countries. For example, Japan doesn't have a lot of natural resources, and so what happens is it imports a lot of the natural resources that it needs. So when we talk about natural resources, it's also the ability to get at those natural resources. We might be plentiful in oil, but if we're not able to get at that oil, then our natural resources per worker would be lower. Technological knowledge is kind of a byproduct of innovation, and it does really point itself at productivity. But one of the things that we do when we measure productivity is we like to be able to measure productivity with other times and other circumstances. So for example, here, the example of Henry Ford in the assembly line, well, that was a very long time ago. So one of the things that we do when we actually calculate productivity using the Cobb-Douglas production function, which we're going to use in just a few minutes, is we actually hold technology constant. And we will call this variable A, and that will be technological knowledge. And again, things that spur innovation. So an advance in knowledge that boosts productivity is anything that we would throw into this category. So where does that come from? There's the million-dollar question. We'd like to say human capital creates a lot of technological knowledge. And so again, it's a byproduct of some of these others, but when we actually go to measure it, we hold it constant. Okay, so again, technological knowledge versus human capital. Human capital results from people, okay, and technological knowledge is the best way to produce goods and services. So the best way to do it and the effort that's needed to do it are really what contributes to this idea of productivity. Again, outputs divided by inputs. Okay, so our second learning objective for Module 6, the second part of Learning Objective 2 is to demonstrate how do we determine productivity. So let's go ahead and do that using the variables that we've. So this is a very, very simple production function. And all we're saying here is, and let me minimize this for just a moment so I can kind of talk about it a little bit better. There we go. Okay. I'm just going to pull this over here just a little bit. Okay, so when we look at this idea of the production function, we're going to say Y is going to be output, or in our case, GDP, just like it was in Chapter 23. And we're going to say the output, if we hold technology constant, it's a function, just like a mathematical function, or it's dependent on the amount of labor that we have, the amount of capital that we have, the amount of human resources that we have, or human capital, and the amount of natural resources. So all of those things together at the given state of technology is what determines gross domestic product. Okay? So that's kind of the really easy, very, very easy way of looking at the production function. Now again, we can measure each of these like per worker. So I could put L over L, labor over labor, which would end up being 1. I could put capital per worker. I could put human capital per worker. I could put natural resources per worker, technology per worker, and then I would have output per worker. So that's one way I could do that. And I could use any of these variables if I wanted to. I could look at output or GDP per natural resources. And then I would have technology over natural resources is a function of labor over natural resources, capital over natural resources, human capital over natural resources, and lastly, natural resources over natural resources, which would be 1. So when you look at this, the idea here is just basically trying to show you if we make a change in things like labor, capital, human capital, or natural resources, given a current state of technology, that we will see a corresponding effect in output. And that's what we mean by this idea of the production function has constant returns to scale. So if we change all of our inputs by the same percentage, then the output will change by that same percentage. So this is a pretty good example here. Notice we're keeping technology constant, but if we double all of our inputs, then we get a corresponding doubling of outputs. Again, same example here, but using 10%, because again, you multiply it by 110 or 1.1 because you get your actual and then your return to it. So that would be the 1.1 that we're coming up with here. Again, holding technology constant. So we're saying the output is a function of the current state of technology held constant, and then increasing each of these inputs: labor, increasing capital, increasing human capital, and natural resources. So that's what we mean by constant returns to scale. So again, I can look at this in different ways. And again, output per worker being one of them. I could look at it by natural resources per worker, human capital. I could use any of these particular variables here and set them over themselves to measure any of these ideas of physical capital per worker or what have you. Just depends on what I want to look at in terms of the production function. Okay, so here's a little question for discussion. Which of the following policies do you think would be most effective in boosting growth and living standards in a poor country over time? So if you have a country like the book depicts, say Mali, and what you want to do is to increase their standard of living, You want to increase output. So just take a minute and think about which one of these things that you would do. And it's kind of interesting because there really isn't a right answer. There are lots of different ways of getting at the problems, and what works in one country might not necessarily work in another. And so what we try to do is to think about, the different countries, the needs, and so on. A lot of times if you have, in poor countries, the children will not necessarily be, are not necessarily there for children's sake, not to carry on a lineage, or, some of those kind of things. The children are actually a byproduct of ensuring that the household can meet its basic needs for food and clothing and shelter and so on. So a lot of times things like giving payments for school attendance, school's not an option, because if you think about it this way, the child can go to school or they can work panning gold or doing some kind of menial task, which gives that household money, which they can in turn buy food or rice and what have you. So sometimes school attendance becomes really difficult. Also, a lot of these different countries have a lot of corruption, and corruption is not necessarily viewed as a bad thing. Corruption is viewed simply as a way of life. So again, just kind of some different ideas. Again, no right answer here, just to kind of get you thinking about, what would be the best way to spur economic growth in a developing nation. Okay, that concludes Learning Objective 2, and I'll see you for Learning Objective 3. Thanks.